Hello and welcome back to Burt's Basic, Box Elder High School, Medical Anatomy and Physiology. We're glad you could join us today. So today we are finishing off Unit 1, which is all about homeostasis, stress, positive feedback, and negative feedback. So let's go ahead and start with the word homeostasis, because these are the things that you need to know in this unit. It says examine relations between homeostasis and stress, which in high school I think you guys got stress down pat. And then it says explain the difference between positive feedback and negative feedback. But we can't really talk about those until you know homeostasis. So let's start there. The easiest way to explain homeostasis is just with a simple diagram. The more you learn about the human body, the more you realize how amazing it is. It is one of the most remarkable things in the world. However, there are a set of rules it has to abide by. And if you get out of those rules, you're in trouble. We all know that homo and homeo means same, and asis means state or condition. So homeostasis is basically defined as the same state or condition. I like to really teach it as a box. So here's my cell phone. Okay, that box is what you have to live in. So if you get above that box, you're going to start to be in trouble. So the body's going to try everything in its power to get back into that box. And this box is homeostasis. Now the key in this class is you're going to learn what this box is. For example, our blood has a pH of 7.4. That means it's a slightly basic, and I have to keep it near 7.4. If I go to 7.6, 7.7, 7.8, we're in trouble. Okay, we're going to get pretty sick and our head could fall off. Okay, maybe not that much, but we're going to be in trouble. And if we go below that, 7.2, 7.1, 7.0, we're in trouble. So for each thing we learn in the body, you have to learn the box. And that's what homeostasis is all about. So in order to truly get homeostasis, this is the most simple diagram around, but I'm hoping this makes sense. Let me move my face down here. I got a big head. Okay, there we go. There's only 3 parts of homeostasis. Number 1, if something does get out of that box, I need a receptor. A receptor we're going to talk about in Unit 6. Those are sensory neurons, and they basically have one job. They're a tattletale. So they're going to tell the brain, hey, we're out of our box. The trick is they don't fix anything, though. So then they go to the control center, which in our case, our control center will be our spine and our brain in the dorsal cavity. And the brain and spine will then make a decision, and they'll send something out on an effector. And sometimes we get really close outside the box. If you look over here, and sometimes we get really close outside the box. But as long as we stay in this blue box, we're in homeostasis, which in chemistry, a lot of times we call equilibrium. The second you get out of this box, things are going to go awry. Now, humans are so amazing that electricians stole our brain's design. And this is just something to help you kind of see maybe a little bit better. But if you look at the basic house, so right now, let's say it's wintertime. Your house is really cold, you set it at 72. That's how this begins. So the first thing that happens is you have to have a stimulus or a sensory neuron. In this case, it's your thermometer. If I have my house set at 72 and it's getting colder, so let's go down to the bottom. So this thermometer reads 71, 70. It's going to freak out and tell the thermostat we are cold. And the thermostat has to make a decision. Now this is the most simple homeostatic pathway in the world. Do I turn on the furnace or do I not? Your human brain has kind of a lot more options. In this case, he turns on the heat, and the motor neuron, or the effector, is the one that's the furnace making it heat. Now, here's the trick. This furnace is going to run forever until a sensory neuron tells the thermostat to turn off. This is how your house works. So guess what happens if you have a bad thermometer? Your thermostat will never know, and your heater will never turn on. So this is kind of how our brain works. Now, you guys got the basic, which is really good. So now let's talk about stress. So stress anatomically is anything that gets you out of homeostasis. Now here at Box Elder High School, I teach anatomy, I teach driver's ed, I teach advanced anatomy and physiology, I teach so many classes. I have seen some kids where I give them a test, they hyperventilate because they're stressed. Now some things cause different stress. Ah, that's a clown. Okay, sorry, I just had to try. A stress is anything that gets you out of homeostasis. It could make your heart beat, can make you have a little anxiety, it can make you sweat. The whole point is, how do we get out of it? The easiest way to get out of it is a process called negative feedback. And that's what this guy is, negative feedback. Now, 95% of the time, that's a Bertolla lie. I don't know if that's the true number, but I'm telling you, negative feedback happens almost all the time. And we'll talk about the keywords in just a second. But here's an example. Now, this looks scary, but remember, stick with it. It's just a receptor that tells me something. The brain makes a decision. The motor carries it out. It's just a 3-part system. In this case, let's say our blood sugar rises. As soon as our blood sugar rises, the neurons are going to tell my brain that, oh my goodness, our blood sugar is really high. And the brain's going to be like, oh, no problem, we got this. It's going to send a message to the pancreas, and the pancreas is going to release insulin. Insulin then will flood all the body cells and tell the body cells, hey, our blood sugar is really high, please take it in. So you can see your glucose will go into your liver. All of a sudden, all these cells will start absorbing sugar. And here is the key word of the century for negative feedback. The key word is opposite. If you do negative feedback, the key to this definition is whatever I am told, I'm going to do the opposite of. It happens all the time. So what happens when my body temperature rises? If I get hot, 101, 102, 103, man, I'm going to start sweating and do anything I can to bring it back down. What if my blood sugar rises? I'm going to lower it. Okay, what if my pH goes too low? I'm going to raise it. The key to negative feedback is whatever my original source is, I'm going to do the opposite. Okay, and some of you are like this. Well, no matter what I tell you to do, you will do the opposite. So I'll be like, do you want, pancakes or toast? And you'll be like, waffles. Okay, you are a negative person. You are a negative feedback person. Negative feedback happens all the time. So obviously, if negative feedback's opposite, you can probably figure out what positive feedback is then. So here's positive feedback. Positive feedback, sorry, you can see it says 5% of the time because that's just our math. This one's a little more tricky. Now, I always talk about this in class. It's kind of stupid. Positive feedback would be example if my body temperature goes 101, 102. Instead of finding the opposite, positive feedback supports it. So that means if my temperature is 101, 102, that means I'll be like, let's go 104, okay? It doesn't make much sense unless you look at these following diagrams. What if my blood sugar is really low? Well, then let's go even lower, okay? It doesn't make sense unless you see it in its proper light. So now keep supports in your mind. Let me get rid of that and let's take a peek. How about this? During childbirth, the uterus is contracting really hard. It's pushing the fetus towards the cervix, and the cervix is stretching. Now, as soon as the cervix stretches, negative feedback would say, hey, brain, our cervix is stretching. And the brain would be like, okay, shut it down. Last time I checked, you can't do that during birth. And so the brain does the following. Instead, it says, I know my cervix is stretching. But guess what? We're giving birth. Not only is it stretching, but we have to stretch even more. And the contractions get a little more violent and a little more violent, and it stretches more and more. So a lot of people teach positive feedback is going further away from homeostasis. I really don't like it to look at it that way. I like to look at it as you have to do positive feedback to return to homeostasis sooner. And you have to get that baby out. So the sooner that baby comes out, the quicker you can get back to homeostasis. On the other side, you over here have a blood vessel. If you have a broken blood vessel, we're going to talk about in the blood unit that as soon as you get a blood vessel tear, platelets or thrombocytes will begin to stick. Now your brain's going to get that information and you're going to be like, well, hey, thrombocytes are sticking. Negative feedback will be like, get rid of them. You can't do that because then you bleed to death. So that's when the brain says, okay, I know platelets are sticking, but they're sticking for a reason. Let's send more. The biggest two things you need to know about positive feedback is the following. It will support, and it will help, and it will enhance. And there's only mostly 10 times this happens. Injury and infection and childbirth are my two main parts of positive feedback. So now if we go back to your questions up here, these are the things you're supposed to know in this unit. You're supposed to know the relationship between homeostasis and stress, and the difference between positive and negative feedback. So I hope you guys enjoyed the videos on Unit 1. Please come back, and we will talk about more. Thank you very much.